Right here. All right, so this is Jasmine is a x86 assembly emulator. Just an easy way to practice in this. So if you click New File, and in the unlikely event that it actually listens to me, it looks like this Windows machine may have, nope, it's moving. It didn't die. Okay, here it is. So what you have here is you have the registers here, EAX, EBX, ECX, and so on. Here you have the floating point registers. I don't care about them. Here you have memory. And this thing only has like a couple of K of memory. And you can see it in various ways. Here it is in decimal. No, descending. It's ascending. Here's hex. There's highlight something. Here's hex. You can see addresses either in base 10, 048, or you can see them in hex. 0x048C and so on. This is what you see here. Now I wonder if I can change the font. It may be possible. Let's see. File, configuration. I have to wait for it to respond. Okay, there. I can change the font. Good. Let's make it bigger. All right. And now I'd like to save the, well, maybe I'm okay. But if I do that, if I go back to here, is it bigger? It did not get bigger. Maybe if I make a new document, it will get bigger. New file. I gotta wait for it to slowly respond. All right, it did not get bigger. Oh, this part got bigger. Okay, well, that'll do. I'll settle for that part getting bigger. All right, so anyway, now you can run simple assembly programs in here. It's just a way to get to see your assembly code run. So we're gonna put in move EAX4. All right, so let me shove this over to the side. All right, move EAX4, EAX. And notice it changes colors when your command is not complete. I think it changes to red when it can't understand you. And down here it even explains to you how the command works. So it teaches you assembler. So I can put that command there, then I can move what? EBX, let me see what else I plan to do here. EBX6, okay. All right. And now it hasn't done this yet. EAX is sitting at 0 and EBX is 0. I can run the program here. I can run the whole program, or I can step through. The green one shows you the current instruction. So I can execute one command, and now it puts a 4 in EAX. Execute another one, and it puts a 6 in EBX over there. So that's all it's doing. All right. And you can, so now we can do more code, and it's just plain text. You can copy and paste it. So I can, right, I'm just going to delete all this and then paste. I'm going to reset to move the pointer back up to the start. Okay, and then paste. All right, and so now I can do these things. I put 4 in EAX, put a 6 in EBX. You see them appearing over there. Then I'm going to move EBX to the pointer EAX. So that's going to move the value 6 to the address 4. And so it appears over here. Now I have a 0006 in there. And, all right. And now I can continue. That's going to move EAX into ECX. So now I have 4 down here. And then I can add ECX to EBX, which makes it to 10. And then I can move ECX to EAX plus 4, which is going to put a 10 here, which shows up as an A in hexadecimal. So I have 6 and A. And I don't think zoom in works on the Twitch. I see part of that was covered by my face. Let me see if I can move this down and make it fit down here. All right, there. So you see I have, it's tiny, but I think you can see it in the Twitch. I've got now I have a 6 here and a 10 there, which is an A, and it's a 32-bit number, so it's got 8 hexadecimal digits there. All right, so that's what those commands do. And now you can use the stack. Let's try these. Copy that stuff, delete this stuff, and reset it, and paste in the new stuff. All right, Now, this is going to again start by putting 4 and 6 in the registers, and then I'm going to push EAX. Now, when I push EAX, it goes into memory, and the way Jasmine works is it puts the stack at the bottom of the memory. So there it is, put the 4 at the bottom there. And when I push it again, it's going to push EBX up here, so I have the 4 and the 6 there appearing at the bottom of the memory. So that's how the stack works. And we can use pop also. I can pop ECX after this. Come on, enter, pop ECX. Now when I execute that command, notice down here, it highlights the stack frame. Right now the active stack frame contains these 2 green points, these 2 green values, 4 and 6. When I execute the pop command into ECX, ECX right now contains 0. When I execute that command, 6 moves into ECX. The green shaded area changes, but the 6 still remains there. And this is the way it really works. It no longer has reserved that space for use by this stack frame, but it's left over on the stack. And that's why the vulnerabilities I've been talking about exist. If you forget to put the arguments in your function call, it will find random data left over in the stack from previous function calls. All right. And so you can reverse a sequence here. This one here. If I clean up this stuff and paste and reset it and put in the new stuff. All right, so now it's going to move these things into the registers. 1, 2, 3, and 4. So now I have those in the first 4 registers. Then it's going to push them on the stack. 1, 2, you're not listening to me. 1, 2, 3, and 4. So now I have those things in that order on the stack, and when you pop them from the stack and put them back in, they're going to be in reverse order. It's going to be 4, go to EAX, then 3, 2, 1. That's the whole point of the stack, last in, first out. All right, and so there's some code to run that will make a secret message, and you'll see it. There is a thing called the console here. There's a part of memory where if you put in ASCII characters, it'll appear in this console, and that's here. So you can have that, and then I think it's if you put things at the bottom of memory, they'll go in. So if I clear this, let's reset this, and clear it, and let's just try pushing some readable characters, like push 0x41. That should be a capital A. Okay, I guess it doesn't show up there, but anyway, there's some part of memory where things you put in there appear here. Push 0. Anyway, I don't know why I'm not seeing it in the console, but anyway, this program should do it. It should print something out, and you'll be able to get various secret messages from here. You have to play with those to find the flags. So that's what I wanted to show you. It's a way to practice assembly code in the simplest possible case. So let me stop this recording.